Now for section 3.3, we're going to start talking about the slope of a line, which is the inclination of a line. Is it really slanted? Is it barely slanted? So that's what the slope is. If you were traveling from left to right, you can see how this line right here, it looks like it's going up, my blue line. So my slope will be a positive value because it's looking up. Now looking at this other one, looking from left to right, we always read from left to right, so here, looking from left to right, it looks like it's going down. My slope will be a negative value. So just by looking at the line, real quick, you should know the sign of it, either positive or negative. Remember, it's always traveling from left to right. So let's take a look at these. My example A, I expect a positive value. My example B, I expect a negative value. For slope, most of the time we do it in fractions. So let's take a look. You need 2 points. You need 2 points on the graph. And traveling from left to right, it seems like it's going up. You can easily count the squares. It's going up 3 squares. So it's going to be a positive 3 on top, right? Positive 3. Then, remember, all my slopes, the inclination, look at this as directions. Like, so you're going to go travel from one point to another point. You went up 3, but then you have to go 2 to the right. So it's positive 2. My fraction, what is going to be representing, the top number tells me whether I go up or down. So notice I said up 3. If you're going up, it's positive. If you're going down, it's negative. Now the bottom number is going to tell me whether I go to the right or to the left. To the right is positive, to the left is negative. So this one says go up 3 and 2 to the right. Notice how my number, it's a positive value. It's fine if it's a fraction. Most of our slopes are going to be fractions. So that's the solution for A. My slope is 3 over 2. Let's take a look at my second example. I'm going to travel from this point. It seems like this case I'm going down, and I can count the squares. 1, 2, 3, 4. So negative 4. But now it seems like I'm going 2 to the right. And then simplify your fraction if possible. Negative divided by positive, I know the sign is negative, which I expected my answer to be negative. Now the fraction, 4 over 2, I can simplify that to just 2. I said most of the time our ratio will be fractions, but obviously not always. Like most of the time they will, but not always. So it's okay. So negative 2 is fine for a ratio, for the slope. Fractions are fine as well. But whenever I give you guys a graph, you can easily count the squares, right? It's easy to count the squares. The problem will be when you don't have a graph. You can create a graph, plot those points, and count the squares. Or there's a formula. I'm going to go over it in class of how the formula came up. The formula we're going to use is y2 minus y1 over x2 minus x1. Once again, in class, I'm going to go over how this formula is created. But what it means is the second y minus the first y over the second x minus the first x. So see how this are the x and the y values of the first point. So that's what we call x1, y1. This other one are the x and the y of the second point. So that's what we call x2, y2. So based on my formula, I'm going to go negative 2 minus 7. Right, there is a minus. Notice how I have a minus in my formula. At the bottom, I'm going to have 1 minus a negative 4. Once again, there is a minus, so don't forget your minus. My 4 is negative, so don't forget the negative. Now, looking on the top, negative 2 and negative 7, we know that's a negative 9. That we can add that. Now here, two negative signs together, that makes a positive sign. So at the bottom, I'm looking at this as 1 plus 4, which I'm going to call 5. Simplify your fraction if possible. So if I could make my number smaller by dividing them by the same thing, do so. In this case, I cannot. 9 and 5, the only thing I can divide them by is 1. So, but nothing is going to happen. So at least the negative sign, bring it to the front. So my answer should be negative 9 over 5. If the negative sign is on top or the bottom, but there's only one negative sign, just bring it to the front. Negative 9 over 5. Let's take a look at my example B. I'm just going to go, using the formula, I'm just going to go 5 minus a negative 2. Remember the second y minus the first y over 12 minus a negative 9. The second x minus the first x. When I see two negative signs together, I'm going to make it into a plus. So on the top, I'm looking at this as 5 plus 2, which I call 7. At the bottom, two negative signs, let me make it into a plus sign. 12 plus 9, I'm going to call that 21. Now these, I can simplify. Let me divide each by 7. So I'm going to call this 1 over 3. Positive, so 1 over 3. So whenever we have the graph, yeah, we can count the squares. When we don't have the graph, we're going to be using this formula. Now let's move on. Let's take a look at more work. Find the slope of each line. Okay, so there's two cases. Like we don't have 2 points. So get 2 points. The way this section, the way we're going to be doing it in this section, we're just going to come over and get 2 points, 2 solutions. So I'm going to say, well, let x equal 0 if we want, or y equals 0. So I'm going to choose a value of x and y, or better yet, I'm going to do something else. I know I'm getting ahead on this one. I'm getting ahead from this section, but I don't want to confuse you. I'm going to help you guys a little. Let's get the y by itself. So I'm going to move, so I'm going to separate them to the equal sign. I'm going to move the 2x to the other side. So I'm going to have negative 5y equals negative 2x plus 4. Right? I moved the 2x, so make sure you change the sign. Now, divide everything by negative 5, because that's the number in front of the y equals, notice here to have negative divided by negative, so I'm going to write 2 over 5x. It's fine if we have a fraction. Now here, positive divided by negative, I'm going to write negative 4 over 5. I know we have fractions in both cases, but we can deal with this. Get the y by itself. Now the slope is the number that comes with the x. So my slope in this case is 2 over 5. Once again, get the y by itself, and the slope is the number that comes with the x. All right, let's take a look at my example B. All right, separate them through the equal sign. I'm going to move the x to the other side as a negative 8x. So I have that 4y equals negative 8x plus 1. I'm going to divide both sides by 4. All right, everything divided by 4. So y equals negative 2x, right? Negative 8 divided by 4 is negative 2. Negative 2x plus 1/4. Once again, the slope is the number that comes with the x. So in this case, negative 2. Once again, I'm getting a little bit ahead from the next section, but this is going to help you guys a lot. I decide whether each pair is parallel, perpendicular, or neither. Let's find the slope of each. Right, x plus 2y equals 7. Let's take a look at my first equation. X plus 2y equals 7. Get the y by itself, right? So I'm going to subtract the x. So I have 2y equals negative x plus 7. Divide everything by 2. Y equals negative 1/2 x plus 7 over 2. I just care for the slope. So the slope, I'm going to put in parentheses here. The slope of the first equation, if you see it, I got the y by itself. The slope is negative 1 over 2. Actually, when I'm asked where the lines are parallel, perpendicular, or neither, I care for the slope of each equation. All right, now let me take a look for the slope of the other equation. I have negative 2x plus y equals 3. So let me separate them to the equal sign. My 2x, I'm going to move it here as a positive 2x. So I have y equals, since I cannot combine these, I'm going to write 2x plus 3. The y is already by itself, so my slope is 2. Now, if the slopes were the same number, right, both cases were the same number, I will call my lines parallel. If my slopes, for them to be perpendicular, there's two things that have to do. One of them, different signs, which I see a negative and a positive. So that's one thing, different signs. And the other thing, they have to be reciprocals of each other. 1 over 2, remember reciprocals when you flip the number? So 1 over 2, if you flip it, gives us 2 over 1, which is basically 2. So notice how there's two things, different signs, they are reciprocals of each other. So my answer for this is perpendicular. Once again, for them to be parallel, my slopes will have to be the exact same number. For them to be perpendicular, they have to have two things, different signs, and they have to be reciprocals of each other. In math, we use the word negative reciprocals, which means different signs and reciprocals of each other. And then for neither, obviously, it's neither of those two cases. Let's take a look at my example B. Let me erase this just for the space. Looking at my first equation, I have 3x minus y equals 4. Separate them through the equal sign. I'm going to move the 3x over. So I have that negative y is equal to negative 3x plus 4. Divide everything by negative 1 because I don't have the y by itself yet. So I have that y equals negative 3 divided by negative 1. That's positive 3x minus 4. So the slope over here, to begin with, the slope is 3. So all I care is for the slope. Let's take a look at the other example. 6x minus 2y equals negative 12. Get the y by itself. So I'm going to move the 6x, obviously switch the sign. So I have that negative 2y equals negative 6x minus 12. Let me divide everything by negative 2. I get y equals negative 6 divided by negative 2. That's 3x plus 6. Right? Negative divided by negative is positive, so that's why plus. 12 divided by 2 is 6. So my slope on my second equation is 3. The same slope. Both of them is 3. If you see my equations, both of them have the same slope. And the cool thing is that they have different number at the end. We're going to call that y-intercept. But we're going to, those are different numbers. So same slope, different values at the end, different y-intercept. This is what makes them parallel. Okay, so that was simple. Hope you guys can finish your work. Any questions, please ask me in class. Or just email me. You guys have my email through my math lab.